Hello everyone, and thanks for joining us for the 7th edition of Programmers Week. This year, we go beyond. For those of you who may not know me, I'm Siggy, and I'm a community lead at Cognizant Softvision, where I mostly keep the big data community engaged via tech talks, challenges, and trainings. Also, I have been here for over 10 years now. I'm really excited to moderate the Inversion of Containers with Kubevirt talk on Cloud Day. The talk is being held by Mircea-Tiberiu Matei, an enthusiastic software engineer with more than 15 years of experience as a full stack developer. From writing documentation, designing hardware architecture, installing and configuring the infrastructure, up to design and develop complete application models or support tools, he has handled tasks in almost any area of software development. I encourage everyone to share your question in the chat module, and we will try to answer them accordingly as time allows it. Without further anticipation, let's get started.
Thank you, Ioan. Hello, everyone. Thank you as well for joining us for Programmers Week. I am Mircea Matei. I'm holding the position of Technical Coordinator at Softvision, Cognizant. I've been here for almost 3 months, and I'm enthusiastic to talk about Kubevirt, and I encourage everyone to share their questions in the Q&A module. I will then answer them accordingly. Without further ado, let's begin. I will start sharing my screen. So, the topic for today is inversion of containers. I placed over there 3 dots because I want to have a wordplay. Basically, most programmers have encountered in their development life the terms of inversion of control. I am assuring you that is not having anything in common with inversion of control, but here we have some cloud tools, something about Kubernetes, something about virtualization, and the name of the presentation is, as you see, inversion of containers with Kubevirt. The agenda contains 5 modules, one for introduction, the second will cover the main actor, the Kubevirt. The third one is pointing to Vagrant, a great actor in the past that is trying to survive in the new era. And the fourth one will be a demo presenting how easy it is to migrate a VM provision by Vagrant to Kubernetes. From the beginning, I will emphasize that the current presentation is focused around the software developer hat. I will try to bring some hints for solving the problem of development environment isolation in a context that should cope with migration or convergence of VMs workload into a Kubernetes infrastructure. I will start with a question. Are you familiar with this dialogue? A developer is saying, it works on my machine, and the manager replies, if it works on your machine, then we will ship your machine. For those that are not aware of it, you will find a lot of funny memes around the internet. And most, if not all, end with the line. And that is how Docker was born. Overview of virtualization options. If I ask you what is more efficient between run a process versus run a virtual machine, most of us will answer that the process will win the battle. When it comes to security, business perspective, or technical depth, the answer may change for depends. The traditional deployment. At the very beginning, the virtualization was just a dream. The development infrastructure was populated by dinosaurs, herds of applications deployed on computers and servers. One day, as a result of the natural evolution, the mighty Type 1 hypervisor get into the scene. Running directly on the physical server hardware, it provides the ecosystem for running multiple guest OSs as home for the targeted applications. Some examples for these type 1 hypervisors would be Hyper-V, Oracle VM, VMware ESXi, VMware vSphere, and the list may continue. They bring efficiency, availability, and high security. Huge step from the infrastructure point of view, type 1 hypervisor were far away from the software developer seat. Trying to bring the same advantages, but closer to the developer seat, another form of hypervisor was released. Running on a host operating system with software virtualization, the type 2 hypervisors came with lower security than the type 1, but with the highest advantage of being controlled directly on the developer machine. Such type 2 hypervisors examples could be KVM, VirtualBox, VMware Server, Hyper-V. Type 2 hypervisor was the closest friend of the developer for years, but finally, a new alternative obscured the VMs. And that alternative have a name, containers. I recall a very nice quote: containers look, taste, and smell the same, just better. Being a concept around the process isolation, the containers provide a very lightweight virtualization environment in which we can host our application. They come with speed, efficiency, and high horizontal scalability. In the Linux world, the concept of containers showed up in 2005 with OpenVZ, but Unix kernels like FreeBSD has this concept since '99 and calls it jails. Both container technologies, Docker in Linux and jails in FreeBSD, have the same concept of lightweight virtualization, but for sure they are having different implementations. Here I am presenting a comparison between those three virtualization options with some features, and on those features, what attribute has each variant. Moving forward, let's introduce the context for the problem that we are trying to solve today. Being the architectural style of most of the modern applications, microservices enables organizations to evolve their technology stack in a rapid, frequent, and reliable delivery track. Microservices come with unbeatable advantages like highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, owned by a small team. But there are cases, and those cases are not rare at all, when the new architecture should replace an existing monolithic one. In the presenting context, we add an extra constraint. We have at least one VM image with an application workload that needs to be integrated. It is self-understood that the virtualized application is needed in a unified workload side by side with other microservices applications. Let's have a quick discussion on the alternatives that we have. If the VM workloads can be moved to containers, then it's a migration. We replace the VM by lifting its applications into one or more containers. This is the happy end. But what happens on this branch if the VM workload from a business perspective or technical point of view, it is impossible to be replaced? Some examples can arise from Windows or Unix applications that are not supported for containerization, at least on the Kubernetes, for example. In that case, the doubled infrastructure could solve the dilemma in a very primitive way. We will double our infrastructure and we will have side by side an infrastructure of VMs and another infrastructure for containers. I will add two questions to this context. The question one, I am a software engineer. How would I replicate the production environment for an isolated development environment? And the second question that came from a DevOps engineer, how would I set up secure provision manage the production environment in order to be aligned with the development outcome? And both questions, for sure, need the same answer. On the previously mentioned context, the answers can be revealed by something that cope with VM and containers in the same way. And the possible answers are Kubevirt, the main actor for today. Other options could be Terraform operator for Kubernetes, Azure Service Operator, that is a Microsoft project as well working on Kubernetes. For other orchestration frameworks, we have Virtlet or maybe Kata containers. Let's move on to Kubevirt. Let's have a short recap. Why we need containers for microservices? Because they provide unit of deployment, simplified testing, unit of versioning, simplified scaling. For the container engine question, I think the de facto answer will be Docker. And for the orchestration, most of us are using Kubernetes. And when it comes to not containerizable workload, I think today's presentation will show you a way on which you can have the VMs and the containers in the same infrastructure. A short presentation of Kubernetes, also known as Case, is an open source system for automating deployment, scaling, and management of containerized applications. The key features are service discovery, load balancing, storage orchestration, automate rollouts, rollbacks, self-healing, secret and configuration management, and horizontal scaling. Some developers use cases on Kubernetes. They will emulate the production locally. They move from Docker Compose to Kubernetes. They allow create end-to-end testing environment for developers. They will ensure the application, it will scale properly, ensure secrets configuration are working properly, performance testing scenarios, workload scenarios. The developers will learn how to leverage deployment options, and as well will help DevOps to create resources and solve problems. Now Kubevirt. What can I do with Kubevirt? Kubevirt leverage Kubernetes to manage virtual machines for impractical to containerize apps. It will combine existing virtualized workloads with new container workloads on the one platform. It will support development of new microservice application in containers that interact with existing virtualizations applications. How Kubevirt will solve our problem? Basically, Kubevirt extends the Kubernetes infrastructure by implementing a custom resource definition with a kind of virtual machine, as you can see here. It can be viewed as a template that declares all common VM parameters and actions. We have a spec of running true or false. We have a template. We have other specs of CPU, devices, disks, the type of the machine, and the resources that we are requesting, and as well the volumes that will be attached. VM disks. So they are mapped to and stored on the persistent volumes. Disk images can be imported using a CDI. If you are not aware of it, CDI is a sister project for Kubernetes. It is managed by CNCF, the Cloud Native Computing Foundation, and can be used to import images and attach them to the VM instances. What about networking? VMs are connected to the regular pod network. There is no difference between a VM and a pod. The VM ports are exposed using services and routes selection using labels and selectors. You can see some of these properties here in the image. If you need some more advanced way of using the networking, you can use MacVTAP that it provides a bind mechanism to the host starting with version 0.35. What is MacVTAP? Is a new device driver meant to simplify virtualized bridge networking. What are the tools that Kubevirt provides? So we have a client tool that we use to start and stop the VMs. We have a VNC to connect to the VM console. We can upload the virtual machine disk images, and as well, we can use the live migration. The client tool can be used in two flavors. One is a kube control plugin. This is the syntax, kube control virtual VNC, for example, test VM2, or as a standalone one, as a binary that is installed on our machine, and the syntax will be virtual control VNC test VM2. Both commands are doing the same thing. I placed here the picture for the main architecture for Kubevirt. As we can see here, we have those gray boxes as Kubevirt components, and the light boxes as Kubernetes components. So, Kubevirt runs virtual machines embedded in pods, running a hypervisor, commonly is libvirt daemon, and they exposes them via Kubernetes services. It's composed of several components, as we can see here. A virtual controller, that is a cluster component that watches for virtual machine custom resource definitions. Its role is to schedule a pod. It is a cluster level resources. It monitors the changes for VM definitions. And if it is the case, it launches them. We have the virtual API, that is the interface to the controller. As well, we have that virtual handler, that is a pod that will manage everything that should be instantiated as VM, and a virtual launcher that stays in each pod for each VM. As well, we can see here that the virtual launcher communicates with libvirt daemon, and using QM or KVM, it will bring our VM to life. A more simplified architecture in this slide. And now a very quick information about Vagrant. Vagrant is something that I used intensively in the past. Before being in touch with containers, I was using Vagrant to deploy locally a lot of machines that are simulating the same environment as in production. If you are aware of it, you know that Vagrant could have a script that it is used in order to provision that VM, and is very easy to use with a command line. What it is the relation to Kubevirt? Currently, you can use Kubevirt VM as you can use Vagrant as a Kubevirt VM controlling tool, and as well you can use as in the past as a Kubevirt image builder. Vagrant, simple and powerful, it provides the same easy workflow regardless of your role as developer, operator, or designer. This code is from their official site. It leverages a declarative configuration file which describes all your software requirements, packages, operating system configuration, users, and more. The scope of Vagrant, it aims to mirror production, as I already told you. It aims to mirror production environments by providing the same operating system, packages, users, and configuration, all while giving users the flexibility to use their favorite editor, IDE, and browser. It integrates with your existing configuration management tooling like Ansible, Chef, Docker, Puppet, or Salt. It works where you work. You will find Vagrant for Mac, Vagrant for Linux, Vagrant for Windows. And now let's go to the next topic, a demo. What I would try to solve with this demo is to show you how easy it is to migrate a Vagrant disk, practically a Vagrant image, that is based on a box with a FreeBSD, and import that image into Kubernetes with the help of Kubevirt. As you can see here, we have a GitHub repo where I placed a README, and that README shows step by step how to complete that demo. I will open that README. As you can see here, we have a very long content, but we will focus our demo today on the third one, experiment with containerized data importer. Basically, how to import a custom FreeBSD image created with Vagrant. If you want to follow these steps, all these steps were made by using the AKS, the Azure Kubernetes Services, provided by Microsoft. You can use maybe a student version account or a Dev Essential version for a developer, or a pay-as-you-go, and trying to move over the steps, it will not charge you more than $20. I will try to show you also what I have already in that AKS, because the time is not enough in order to import the machine, because it takes more than 15 minutes in order to import 4 gigabytes. And as you can see here, all the steps for creating the AKS cluster were already completed. And we have a Kubernetes cluster with 2 node pools. And what is very important to be mentioned here, and I want to mention that you should be aware of version skew policy. You may get into trouble if you use a kube control client with a version that is skewed from the Kubernetes version that you are trying to control more than 1 plus or minus 1 increment on the minor version. As you can see here, I have all the steps for getting connected to that cluster, to create that cluster. What I have to mention as well is everything is focused on a single resource group in order to clean everything when we finished the demo, or when you finished your steps trying to follow this demo. And now let's get to our steps related to migrating that Vagrant box. What we should do in the first place, we should install the CDI, that sister project for Kubernetes that provides an operator and custom resource that will be used to import our disks. As you can see here, the CDI provides facilities to import a disk image, to clone an existing persistent volume claim to a data volume, and as well to upload the local disk image to a data volume. How I am creating that Vagrant box, I will show you the scripts that I have used. All those scripts are attached to this repo. As you can see here, I have a folder named Vagrant, and in that folder I am having two files. A Vagrant file is very easy to understand, that I will configure a VM based on a template that is FreeBSD. That box version will be one from 2021. As well, when Vagrant will launch my box, it will name Vagrant Demo VM. And for some internal purposes, I am naming that host name FreeBSD local, and I will forward some ports from port 80 on the VM to the local host where Vagrant is installed, 8081, in order to test that VM. As well, as we mentioned before, we can provision that box with a custom script, and that custom script is here. It's a very simple one. It will only install the Apache server, and we'll start that Apache as a service, and after that we'll check the status, and that is everything that provision script will do. How Vagrant is working is very easy to start that box. Sorry, I have to change directory to that Vagrant, because in that folder I'm in Bash. Sorry, I was customized with Windows command line. So cd Vagrant, as you can see here, we are in the Vagrant folder, and to start that machine is as easy as Vagrant app. I have started the VM VirtualBox Manager in order to see that the Vagrant demo VM is powered off currently, and the Vagrant will do everything what I have in those two scripts. The Vagrant file that is staying for bringing up the machine, and the script sh that is staying for provisioning. As you can see here, the Vagrant demo VM is already running. I have to wait some minutes in order to get ready with an SSH console. sorry for that. I am seeing a message that the repo is not available, is not public. That is true, and I will make it available as public right after this demo. Now I can check with Vagrant SSH if everything is okay. As you can see here, I'm already logged to the console. The default user for a Vagrant box, if you are not providing something else, is Vagrant, and the password is Vagrant. And here, I can have any comments that that console allows me. I will exit this this console, or maybe I should test if the Apache is running. As you can see here, the Apache is running. If I want to test it locally, is nothing else than moving to my local host and provide that port. As you can see here, the web server responded with a simple page that everything it works. Why this port? As you remember, this port 1881 is provided from the Vagrant script. Okay, so I will release my console. If I want to stop the machine, is very easy. I will Vagrant halt. As you can see here, the running, it stays as the label, but soon that will change to stop. As you can see here, we tear down that virtual machine. Okay, so everything is stopped now. Let's move to the Kubevirt. As I told you, I already provisioned my Kubevirt with the image of this machine. What comments I have used. So after creating that FreeBSD VM using Vagrant, I powered off my VM and I used the CDI importer to import that disk image. I created a data volume with a storage of 10 gigabytes in access mode as read-write once. As you can see here, I have a name of upload data volume. I started the port forwarding for the CDI upload services. And in after completing that command, I will have an open port on my local machine where I can provide that VM in order to be transferred to Kubevirt. As you can see here, in order to secure that communication, a token should be created, and that token, an upload token request should be created, and that token should be provided to the curl command in order to push our image. Our image is from the local host. This command stays for a while because the disk that the Vagrant VM is creating is somewhere around 3 or 4 gigabytes. But all the steps will be shown in the console, and you will see if the command will complete with success. As you can see here, we are completely uploaded and fine. The HTTP shown OK 200. The closing connections and everything after these steps. If we end that comments with completed the upload, in that case, we should be fine for the next step. How to create that VM in Kubevirt? As you can see here, we have the namespace of Kubevirt and the API from Kubevirt. So that virtual machine that I mentioned previously. For that virtual machine, I will provision with a persistent volume claim based on the upload data volume. The upload data volume that was created here. I am explicitly saying that I will need a CPU with 1 core. I will need a disk with SATA bus. The machine type will be Q35, and I will request a memory of 2 gigabytes. Now, everything being completed previously meaning before this demo, I will show you what we have currently in Azure on the Kubernetes. So, we have those 2 node pools, a nested one that will stay as the environment for my virtual machines. I think I mentioned, or if not, I should mention that if you are using Azure, you should use some machines that are able to have nested virtualization. For example, these D3 machines are able to have nested virtualization. Other way, you will be paid for the performance. For workloads, we have a lot of pods, but those that are staying in the Kubevirt namespace are prefixed with virt. We have the operator, we have the API, the controller, we have the virt handler, and as well, we have those that are bounded to the containerized data importer, and those are prefixed with CDI, the operator, the API server, and the upload proxy as well. And now let's play with that VM. In order to connect to that VM, we should create a service. For example, I can create a load balancer service, and that load balancer service will connect my VM 80 port to an external port of 38,883. We have here the type for that service as being a load balancer. And let's play with this. The service is already created. I will test the status for my VMs. As you can see here, my VM is currently stopped because I stopped previously, but it's not hard to move that VM in a started that test VM2. VM is scheduled to be started. I can check. As you can see, the status was changed from stopped to starting. I should wait a little bit. Currently, it is running. As well, I can check the VMI instance for the status. It is running. The internal IP is 10.244.0.15. And now, let's try to connect to that machine. Somehow, the VNC is on the other screen. As we remember, I will use the login as Vagrant. And currently I'm inside that box connected to the console, and I can do everything what I need to do with that machine, and that state that I will change, it will be persisted when the VM will stop. Let's see if we can connect to that machine from the internet. We can see here the external IP for the load balancer is this one. The exposed port is this one. I will copy this. I will move to a browser. As we can see here, everything works. Let's check if we can stop that machine. I will stay with the VNC here in order to see that everything is in sync with that VNC. As you can see, the VM test VM2 was scheduled to stop. On the left side, we have that VNC showing that the connection will go down, and soon everything will freeze because no connection to that machine. So I think this is what I tried to show you today. Maybe we can start it again, because we have 1 more minute. And in the meantime, I want to present you just the name for those 2 demos that are staying in the README. The first one is creating the first Fedora Linux VM using a public Docker container image. If you follow this demo, you will inject an SSH key, and you will connect directly to that machine. But basically, this image is pulled from a web repository. Another one by using a Docker image that is around a Windows installation disk is the second one, creating the first Windows VM using a private Azure Docker registry. It is using the Docker registry service from Azure. It creates an image. That image, if you are curious about how it is created, you have this file. It's very easy. It's nothing else than that ISO wrapped in a container in this path. Nothing else. This is mandatory to stay in this path. And being in this path, the Kubevirt can pull that that image and use as a disk in order to bring that machine to life. So I think we are completed our demo. I will get to my conclusion. The VM is dead, but long live the VM, because we have a way to reuse our VMs that we made in the past, maybe using Vagrant or other tools, and bring them to Kubernetes side by side with other containers. And now let's start the session for the question and answers.
Yeah, so someone from the chat mentioned that the GitHub repository is not public and asked if we can make it public. And
for sure, I have to excuse myself for that missing. I will make it public right away after I will leave this session.
Yeah. Other than this, I think the presentation was crystal clear. No further questions were asked. Thank you everyone for joining us. Make sure to check the Programmers Week webpage for other interesting presentation, and have a great day.